On April 29, 2013, a Boeing 747-400 freighter from National Air Cargo prepares to take off from runway 03 at Bagram Air Base in Afghanistan. The aircraft begins to roll down the runway, rotating normally, and then something catastrophic occurs just a few seconds later. The aircraft pitches violently, and what happens next is captured on dashcam video, which I'm sure anyone who has seen it will remember. The video clearly shows how the aircraft climbs at an almost impossible angle. At one point, the aircraft appears suspended in mid-air before turning over, dropping its right wing, and colliding with the ground. What led to this? As with any accident of this nature, there is not a single cause but a series of events that contributed to it. So, with the help of the final report, let us look at what the links in that chain were made of. Stay tuned. The crew on board National Air Cargo Flight 102 was on their second flight of the day. They had begun the day in Combustion, Afghanistan, where they had loaded their cargo. Then they flew for about 1.5 to 2 hours to Bagram Air Base, where they were scheduled to refuel, check their cargo, and then fly to Al Maktoum International Airport in Dubai. They were flying a converted 747-400 freighter, built in 1993 and sold to Air France. It was operated in France as a combo aircraft for a few years, before being converted into a freighter and sold to National Air Cargo. You'll need to know a few technical details about the 747-400 to understand this accident. So, when it was converted from a passenger aircraft to a cargo aircraft, Telair performed the conversion. They transformed the 747's main deck into a freighter deck designed to house unit load devices, ULDs, also known as containers. The way this is done is that there are rails with ball bearings in the aircraft's floor, as well as locking devices at medium intervals, so you can take one of these containers, push it into nice neat rows, and then flip a little lock switch for each load device. When locked in place, they cannot move, so the load is protected from forward, aft, and side movements. Flying freight requires that the load not move for weight and balance and aircraft safety. Now, there are times when you need to be able to load larger items into these freighters because the containers are simply too small to accommodate what you want to move. To do so, you must also be capable of securing that type of cargo. As a result, the cargo deck has multiple locking points, allowing you to strap larger cargo and lock it in place. However, you must calculate how much G-load each strap can withstand in the front, back, sides, and up and down positions. This is the loadmaster's most important responsibility when dealing with non-standard cargo. You also need to understand the 747's hydraulic system. The 747 has 4 independent hydraulic systems, each powered by its engine. Hydraulic lines run from the engines and hydraulic pumps to each system requiring hydraulics. This includes landing gear, flight spoilers, and the primary flight controls. When it comes to the primary flight controls, which are the ailerons, rudders, and elevators, you have several options. So, if one system fails, you can still control the rudder. You also have a jack screw that is controlled by a hydraulic motor that powers the stabilizer. So, for example, when the pilots are trimming, the jack screw will move the stabilizer up and down depending on the type of trim they need to set, which I've covered in a separate video if you want to see it. The hydraulic fluid lines on the 747 run beneath the main cargo deck floor before passing through the aft pressure bulkhead to their respective PCUs, or power control units, which are the small motors that activate the rudders or elevators as needed. They will also activate the engine that powers the horizontal stabilizer. The aft pressure bulkhead is the pressure vessel's end plate. The back part of the aircraft is where pressurized air is located, and there is no pressurization behind the air pressure bulkhead. Just forward of the air pressure bulkhead, there is a small rack that houses the flight data recorder and cockpit voice recorder. And I'm telling you this because it will be crucial soon. The accident flight had 7 people on board. Captain Brad Heisler was the flight's captain. He was 34 years old and had approximately 6,000 hours of total flight time, but only 400 hours flying the 747. He was accompanied by First Officer Jamie Lee Brokaw, a 33-year-old with 1,100 total hours and only about 209 hours on the 747. In addition to the flight crew, the loadmaster, Michael Sheet, 36, was present on the flight deck. The other onboard passengers included a backup flight crew, a first officer, a captain, and mechanics. We need to talk about the cargo they were transporting on this flight. So, as I previously stated, this 747 was designed to carry these ULDs and containers. Still, the United States Air Force Mobility Command contracted them to have a much larger type of freight on this particular flight. So they were tasked with transporting 5 massive vehicles known as MRAPs, mine-resistant ambush-protected cars. 2 types of vehicles were supposed to be transported. They were supposed to carry 2 smaller versions known as MATVs, each weighing 12 tons, and 3 massive Cougar vehicles weighing 18 tons each. These vehicles were too large to fit into any type of ULD, so they had to be transported on specially built pallets. In fact, the commonly used pallets were too weak, so you had to use double pallets with some plywood in between to spread the weight of these vehicles. So these are huge. These vehicles were then secured to these pallets with chains before being loaded into the 747's centerline loading area. That means they're perfectly aligned with the centerline to prevent the weights from shifting left or right. They were loaded in the following order: the smaller MATV at the back, 3 Cougars in the middle, and another smaller MATV in the front. The loadmaster who was loading these vehicles onto the 747 appears to have yet to use the load manual, even though this was his first time loading a car of this type and the flight crew's first time flying with this type of cargo. At that point, he relied primarily on his previous experience. He calculated the weight of each vehicle, and he thought, all right, for the smaller ones, we're going to need 24 straps to keep it in place. And then for the bigger ones, we would probably take 2 more, so 26 straps. To give you some perspective on this, when the chief loadmaster of National Air Cargo was asked to recalculate how many straps were needed, he initially concluded that he would also put 24 straps, but then he did. Right now, I want to point out that these vehicles aren't just carrying any cargo. All right? They are what is known as a special cargo load. They are longer than the normal special cargo load, which means that there are specific restrictions on how many of these you can carry and how you must restrain these, because if they come loose for any reason, they could seriously damage the aircraft, as well as damage the upper floor, which is where the crew was housed. So, there are very specific rules for carrying out this. All of these rules need to be covered in the loading manual of National Air Cargo Airlines. Incredibly, the loadmaster on this occasion was unaware of these rules. When the FAA began looking into this following the accident, it became clear that not only was the manual incorrectly written, but there was also no specific training required to become a loadmaster. The loadmaster was not subject to any particular training or certification, as a pilot or air traffic controller would be. Individual airlines trained and ensured these employees knew what they were doing. The FAA needed to provide more oversight to prevent such risks and lapses in knowledge and communication. Now you may wonder if the pilot is responsible for ensuring the cargo is properly loaded and secured. Yes, legally, the pilot in command is always responsible for the aircraft's safety. However, this type of responsibility is assigned to the loadmaster. If the loadmaster comes up before the flight and says they're satisfied with how the aircraft is loaded and secured, the pilots will take their word for it. The crew's first flight of the day was from Camp Bastion to Bagram Air Base, and it appears that all went well. There were no indications of a problem during the flight. After landing, as the crew prepared for the next leg over to watch Dubai, it appeared that the loadmaster returned to check on the cargo. He reported to the first officer, who then entered the cockpit. The following conversation was recorded on the cockpit voice recorder and is one of the most chilling conversations I've ever heard in conjunction with an accident. At 14:28 UTC, the first officer informs the captain that one of the straps is broken. He then mentioned a knot and said there were many of these straps, both for keeping it from moving forward and backward, and they were all loose. The augmenting captain was also in the cockpit then and made some jokey remarks about how loose they were. But the captain did not appear amused. In fact, he says, "Well, I hope he's actually beefing them up a bit and not just tying them down." The first officer is in charge while clinching them down. 15 minutes later, the loadmaster appears in the cockpit, and we hear the conversation. The captain asks the loadmaster how far they moved, and the loadmaster responds, "Only a few inches." The captain says, "Oh, that's scary. Are those huge things moving? I don't like that at all." He continues, "Well, I've never heard of such a thing. You would think that those two big, heavy things, you would think that they wouldn't even move at all." The loadmaster responds, "But they always move. Everything moves if it's not tied down properly. The fact that this cargo moved in this manner indicates a serious problem. This conversation shows that the captain and loadmaster know and dislike this. However, they do not appear to understand the full scope of the problem." The aircraft is ready to depart 45 minutes after the initial conversation in the cockpit. They receive their taxi-out clearance and begin to taxi out. There were many conversations in the cockpit then, but nothing was related to the cargo. They are cleared to taxi into position for holding point runway 03 and await a departing aircraft. At 15:25, the aircraft is lined up on the runway and begins its takeoff roll. We have all of the CVR and flight recorder data up to this point, so we know that the engines spooled up normally and that the aircraft accelerated properly, just as it had on the previous flight out of Camp Bastion. The aircraft will then rotate. The first officer requesting gear up is the last recorded on the cockpit voice recorder. Approximately 2 seconds later, all recordings are lost. The flight data recorder and the cockpit voice recorder cease recording. Before they do so, the final 2 to 3 seconds of the aircraft's takeoff indicates an abnormal pitch-up. From this point forward, everything we know is based on eyewitness reports. We've all seen the famous dashcam video. So, we know that following rotation, the aircraft began pitching uncontrollably. According to eyewitnesses, they saw some puffs of white smoke coming out the back of the plane, and the dashcam video captured the last few seconds of the flight, revealing how the aircraft climbed up until it lost all forward airspeed. It pitched slightly to the left, then over to the right, and crashed into the ground at almost wings level. This was not a survivable event, and all 7 crew members died in the accident. The air crash investigation team faced a difficult task, determining why this occurred. In the first case, they went outside and began searching for clues. They began looking at the runway and around taxiway Charlie, approximately where the aircraft would have rotated. They started finding debris. They discovered some pieces of aircraft skin, hydraulic tubing from hydraulic system 2, and an antenna from one of the armored vehicles, the MATV, located in the back of the aircraft. Then as they continued down the runway, they discovered more debris until they arrived at the crash site. The crash site was approximately 590 feet from the northeast departure end of runway 03, and it was fairly well held together. The forward and center sections of the aircraft had been completely destroyed by fire, so there was little they could find. However, they were able to locate all of the armored vehicles, with the last one located near the horizontal stabilizer and vertical fin. They started looking at that mat because the previous part of the aircraft had not been touched by fire, and they discovered some interesting clues. For example, inside the vehicle, they found material from the aircraft's back wall, indicating that the car had come into contact with it before the crash. When the vehicle was crushed on the aft pressure bulkhead, it fractured into several pieces, leaving a tire mark imprint that matched the spare tire on the mat. They also discovered the jack screw used to control the horizontal stabilizer, which had been severed and inserted into the stabilizer. The point where the breakage occurred was also very close to where the mate would have hit it if it had come rolling backward. Based on these discoveries, they could create a picture of what happened during the accident flight. Because they discovered pieces of aircraft skin, hydraulic tubing, and the mate's antenna around taxiway Charlie, at least one of the armored vehicles began to move backward as the aircraft rotated. The first thing the vehicle would have impacted was the rack containing the flight data recorder and cockpit voice recorder, which is why all recording stopped only a few seconds after rotation. The vehicle would then have returned, crashing into the aft pressure bulkhead, where the hydraulic tubing connected to the flight controls, rupturing at least hydraulic systems 1 and 2, and possibly more. If it did this and dropped the hydraulic systems, that could explain the eyewitness account of white puffs of smoke as the aircraft climbed away. Most likely, that was hydraulic fluid being vaporized into the air. As the vehicle continued into the jack screw, it severed it, bending it backward and forcing it into the horizontal stabilizer. This force would have tilted the horizontal stabilizer downward, causing the aircraft's nose to pitch uncontrollably. Because the jack screw had been severed, the flight crew would be unable to control the stabilizer movement, and the loss of hydraulic pressure may have also made control of the elevator impossible. When they looked at the data from the last few seconds of the flight data recorder, it seemed very similar to the pitch-up that would occur if the horizontal stabilizer was pushed down into the position they discovered at the crash site. This paints an absolutely horrific picture of what happened during the last 30 seconds of this flight, because it means that as the crew rotated, the insufficient strapping of at least one of these vehicles would have simply ripped through the straps that held it down, causing all of the damage that we just discussed, effectively disabling the aircraft's pitch control. So the aircraft would have continued to pitch, and no matter what the flight crew did up front, or how hard they pushed the yoke forward, nothing would have changed. Instead, the aircraft would maintain its nose-up attitude until it ran out of momentum, entered an aerodynamic stall, and crashed into the ground. Once the horizontal stabilizer had been damaged, the flight crew would have had no recourse. This video was made possible with the assistance and support of Skillshare, an excellent online learning platform. Now I know you're watching because you're a curious person, a lifelong learner, and someone who strives to improve what they do. If you identify with this description, you should definitely check out Skillshare. They have thousands of high-quality video courses on pretty much anything you can think of, from how to improve your photography for your Instagram feed, or how to improve your YouTube channel, which is something I've been looking into myself, to how to become a private pilot using your home simulator to prepare. Now, the first 1,000 people who use the link in the description below or up here will receive a free trial of Skillshare, which means you can win and see if there's anything in there that piques your interest or curiosity. If there is, it is very affordable. Okay, it's less than $10 per month to sign up, so I highly recommend it. When the National Transportation Safety Board issued its final report, it reached the following conclusion. The National Transportation Safety Board determined that the probable cause of this accident was National Airlines' inadequate procedures for restraining special cargo loads, which resulted in the loadmaster's improper restraint of the cargo that moved aft and damaged hydraulic systems 1 and 2, as well as the horizontal stabilizer drive mechanism components, rendering the airplane uncontrollable. The Federal Aviation Administration's failure to monitor national airlines' handling of special cargo loads contributed to the accident. The NTSB also made several recommendations, including revised guidance material for air cargo operations relating to restraining special cargo loads, as well as the creation of a certification for personnel responsible for loading and restraining special cargo loads, including training and duty time limitations which, believe it or not, did not exist before this point. Enhance cargo airline compliance oversight and train Part 121 cargo inspectors. Thanks for watching. Like, comment, and don't forget to subscribe for more from Shadows of History. See you next time.